Welcome to Hydrocarbons Part 1. This video tutorial is going to focus on the structural formulas, reviewing how to convert from a Lewis structure to a skeletal line or bond line structure to a condensed structure, and vice versa. Let's get started. So here are the three main types of structural formulas. So remember, this is where we've started with a Lewis structure. We show all of the atoms, we show all of the bonds, and we remember to show the lone pair electrons. Alrighty, now this gets to be too much information, so we want to abbreviate it. So to abbreviate it, we can use the skeletal line structure. And here we will simply show the carbon-to-carbon bonds, and then we will show the heteroatoms of the functional groups. Now, when we're writing functional groups, we will include the hydrogens. And then the opposite of a skeletal line structure, where we're focusing on the bonding, we will look at the condensed structure, and this is where we will look at atoms only. Alrighty, so let's start with where we're familiar. So if we were to do the Lewis structure for the this compound here, this will be butanal. We are showing every carbon atom, every hydrogen atom, every bond. And then when we see oxygen, we recognize that we have two lone pairs. All right, so this would be the expanded structural formula or the Lewis structure. Now, once we get familiar with organic compounds, then we want to do abbreviations. So if we took this same compound and we showed it in its skeletal line structure, I'll slide this down, right, we would abbreviate it like this. So each of the corners represents a carbon, and then there is our aldehyde functional group. If we wanted to show this same compound using a condensed formula, we would take advantage of the fact that here's our first carbon atom, and then we know it's bonded to 3 hydrogens, and then our second carbon atom is bonded to 2 hydrogens, and then we keep following the process. And when we get to our functional group here, there's the carbon. We always, if there's a hydrogen bonded to the carbon, it's always listed first, and then we would list the oxygen. So the main thing with condensed structures is recognizing that the carbons are forming the backbone. And then notice too that for the skeletal line structure and the condensed formula, we don't worry about the lone pair electrons unless we're asked a question that's very clear and says we must show them. Alrighty, so let's review some bonding patterns. Now, these abbreviated structural formulas with skeletal line or condensed, these formulas work because we take advantage of knowing our neutral bonding patterns for organic compounds. So, for example, when we look at hydrogen, we know that hydrogen is group 1. It only has 1 valence electron, so hydrogen always wants to have only 1 bond. When we compare this, for example, to carbon, which is group 4, when we look at carbon, we recognize carbon has 4 valence electrons. So when carbon forms compounds, it always wants to form 4 bonds. Of course, carbon doesn't care how it gets those 4 bonds. Carbon doesn't care if it has 4 single bonds, 2 single bonds and a double bond, or a single bond and a triple bond. All carbon cares about is that it always has 4 bonds. Now let's look at another important atom that we'll see in biological molecules. That's nitrogen. Nitrogen is group 5. So nitrogen has 5 valence electrons. So hydrogen already has 2 of its electrons paired. So nitrogen always has a lone pair, and then it likes to form 3 bonds. And just like carbon, nitrogen doesn't care how it gets those 3 bonds. It just cares that it has 3 bonds and 1 lone pair. And then last but not least, let's remind ourselves about oxygen and oxygen's bonding patterns. Oxygen is group 6, so it has 6 valence electrons. So when oxygen forms compounds, it will have 2 sets of lone pairs and 2 bonds. And just like carbon and nitrogen, oxygen doesn't care how it gets its 2 bonds. They could be 2 single bonds or 2 double bonds. And then we have the 2 lone pairs. So it is through the abbreviated structural formulas, whether it's Skeletal-line or Condensed Formula, takes advantage of the fact that we understand these bonding patterns. Let's go to the next page. Now we will review how to draw a skeletal line structure. So let me get this centered, and we'll get started on this next page. Alrighty. So, because of the natural bonding pattern of those tetrahedral bond angles, the carbon atoms make this sawtooth zigzag shape. So the end of every line and every corner corresponds to a carbon atom. So if we counted our carbon atoms here in our Lewis structure, we see we have 5 carbon atoms. So the end of this line represents carbon 1, carbon 2, 3, 4, 5. So these 2, this is our Lewis structure and our skeletal line. They're representing the same compound, pentane. Right? So we'll briefly review the rules. Right? So all carbon-carbon single bonds are shown as a single line. Double bonds are shown as 2 parallel lines, and triple bonds as 3 parallel lines. So for example, if we added a double bond or a triple bond to our compound, let's see here, right? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. All right, so notice that we always ignore the carbon atoms because they're represented as the end of the line or a corner. And let's see, the heteroatoms, it's important to draw those. And that would be, for example, if we have oxygen or nitrogen. So notice in our skeletal line structure, we're not showing the hydrogen atoms because everybody knows that carbon wants to form 4 bonds. And so any missing information is assumed to be hydrogen. However, it is important to show hydrogen when we have functional groups. So for example, if we added an alcohol, right, we would show the hydrogen on the alcohol group. So let's practice this a bit. We have some practice compounds right here. Alrighty. So here we can see the carbons are forming a 6-membered ring. And then we notice that we do have a double bond present on the right side. So we have the Lewis structure and the skeletal line structure. Now here we have an alcohol. We have 1, 2, 3, 4. We have a 4-carbon chain. So start with our backbone, our 4-carbon chain. And then we notice that coming off the second carbon, we have the alcohol group. And then last but not least, here we have another 6-membered ring, but we have the nitrogen atom present. So each corner represents a carbon, and then we show the double bonds. And then if the question asks, we can always add the lone pairs, remembering that a neutral oxygen wants 2 lone pairs and nitrogen a single lone pair to complete the octet. Alrighty, so now let's review condensed formulas. All right, because we recognize that the carbon atoms form the backbone, it's really common to omit those bonds. For a 300 series class, it's very common to show the double or the triple bonds, so you don't have to do too much investigative work. The main thing to keep in mind with the condensed formula is that we have our carbon backbone, so we recognize our bonding pattern, that the carbons are all going to be bonded together. So the convention of the condensed formula then is, here's our first carbon. We would list any hydrogens bonded to that carbon. If there were any other functional groups or branches, they would be included as parentheses. Then we would go to our next carbon in the backbone, and we would list any hydrogens bonded to that carbon, and then any branches or functional groups would be in parentheses. And so we would continue building our carbon chain with this same pattern, listing the carbon and then all of the atoms bonded until we get to the last carbon on the right. And this pattern can continue for as large as the molecule is. So these 3 structures, right, we have our Lewis structure, our condensed formula, and our skeletal line bond line structure. So these are all representing the same compound. So recognizing, here's our 1, 2, 3, there's our 5 carbons, our 5 carbons, and our 5 carbons. So we will, so let's practice this. So we will talk about and define structural isomers. You should already know structural isomers from your notes, and we'll review that in the hydrocarbon part 2 video, right? So structural isomers, here's an example. All 5 of these compounds all have the chemical formula C6H14, but we see that because of the versatility of carbon, we are able to connect those 6 carbon atoms in very different arrangements. So we just start. So this first carbon here, since we only see 1 bond, we know it must be bonded to 3 other hydrogens. And then notice we're going to have 1, 2, 3, 4. We have 4 carbons in the center. They're all the same. So we can simplify and show that this represents the 4 CH2 groups in the middle. And then we're to the terminal carbon on the end. And so there's our condensed formula. You're also free to write this out 4 times if you don't mind. Alrighty. Now let's look at this next structural isomer of C6H14. Now we can represent this, we can just focus on the skeleton and treat this as a branch. So let's do it that way first. So here is our terminal carbon, CH3, and then we get to this carbon with a branch. So since carbon wants 4 bonds, we recognize that there's a hydrogen that hasn't been shown, and then we would use the parentheses to show the CH3 group coming off right here. And then we would continue along the carbon chain, CH2, CH2, CH3. With this molecule, though, it is common to see the condensed formula written slightly differently. We could consider both of these carbons a branch on this carbon right here. So an alternative way to write the condensed formula for this compound would be to put the 2 CH3 groups at the beginning, and then we would get to the carbon with our arrow, CH, and then we would continue as we did before. So there are no official rules on condensed formula, so you want to be comfortable drawing a condensed formula or reading a condensed formula either way. These both represent the compound above. Once the branch gets into the middle of the chain, it's much more straightforward. So we begin with our first carbon, CH3, and then a CH2. And then we get to where we have our branch. So this carbon only shows 3 bonds, so we know it must have a hydrogen. And then there's our branch. We'll show that with parentheses. And then we can continue on with our carbon chain. There we go. Alrighty. Okay, let's keep working our way. Now this one in particular, this is another example where we have 2 alternatives. We can think of this as a 4-carbon parent with 2 1-carbon branches. So if we view it this way, we would write carbon 1, CH3, and then when we get to carbon 2, right, it has 4 bonds. There are no hydrogens. We would draw carbon 2, and then we would indicate that it has 2 1-carbon methyl branches. And then we would continue along our chain to carbon 3 and carbon 4. It is also possible to view this beginning with carbon 2 and viewing all 3 of these carbon branches. So you may see this compound written this way, with the 3 carbon branches coming off of the carbon with the arrow, and then that would leave us with CH2, CH3 to finish. So in each of these cases, both forms are correct, and you want to be able to recognize them. Alrighty, and then this last structural isomer here, we can just continue this one when the branches are to the inside. We have CH3, and then we get to carbon 2. It has 1 hydrogen, and then a branch. And then we get to carbon 3. It has 1 hydrogen and a 1-carbon branch. And then we get to carbon 4. So condensed formulas are important, especially on exams, because a lot of times professors use questions from a test bank, and often the test bank communicates the structure as a condensed formula. So you want to be very comfortable. Now let's do a brief review of what we've just practiced before you get started on your homework. Alrighty. So basically, we have 4 different ways to describe organic compounds. The first one, the molecular formula, could also be the chemical formula. And we haven't really talked about this in the video, and the reason for that is because there is no structural information. However, sometimes after we've talked about structural formulas, students kind of get confused when they hear molecular or chemical formula. So I wanted to remind you that this is simply an inventory. How many carbons, how many hydrogens, how many oxygens, are there nitrogens present? Are there any phosphorus atoms present? Right? So there's no structural information, but it can still be useful information. Now, this is where we focused on this video tutorial, right? Lewis structure, or expanded, shows everything. All atoms, bonds, and lone pairs. The bond line, or skeletal-line structure, remember, only shows carbon-to-carbon bonds and the atoms of the functional groups. And then last but not least, we have the condensed formula, which is basically atoms only. And it's perfectly okay. And in my class, I will always show you any double or triple bonds. Alrighty. So now let's take some time to convert back and forth. Alrighty. And this first example, I've asked you to show, we've shown the skeletal line, and I've asked you to draw the 3 other ways. But for ringed structures, there's no condensed formula. So we can skip that part. So we can do the Lewis structure though, right? Recognizing that the corner of every line is a carbon atom. And then we see that we have a double bond, and then we have a bond to oxygen, and then that bonds to hydrogen. Okay, now is where our bonding patterns come into play. We know all of the carbons want to have 4 bonds. As we look at this carbon here, we see that it must be bonded to 1 additional hydrogen, just like this carbon. These carbons, however, only have 2 bonds. So we recognize that there must be 2 additional bonds to hydrogen. When we look at this carbon right here, 1, 2, 3, it only has 3 bonds present. So we're going to have to add 1 more hydrogen. And then last but not least, because we've been asked to include lone pairs, and we always include lone pairs in the Lewis structure, now our molecule is complete. So since we can't do a condensed formula for this ring, the only thing left to do is write the chemical formula. So that would be C5H12. Oh, no, not H12. H8O. Okay. Alrighty. Now, with condensed formulas, this was also a good opportunity to remind you of the one time we can show a ring, right? When we have a compound like this, a benzene ring, this is the only ring that we can show a condensed formula for. This would be C6H5W. So slide that little bit of tidbit in there for you. Alrighty, so let's keep practicing. Now we have a condensed formula, so we can draw all the other forms. I think the Lewis structure is the one we're most familiar with, so when in doubt, create the Lewis structure. And then from this Lewis structure, you can convert to the other forms. Here we have a CHO, that's the CHO, that's an aldehyde. You'll recognize that very soon. We'll start with, that's our first carbon, and then we notice we have 1, 2 more carbons in our chain. And then we notice that we have 2 carbons coming off of this carbon with the arrow. Alrighty, so we've created our carbon skeleton. Now we take advantage of our bonding patterns. If we look here, this is telling us that this hydrogen is bonded to carbon because it follows directly behind. So then we would have an oxygen. Let's keep going. Here we have our CH2, so we put in our 2 hydrogens. And then we have our carbon, it has 1 hydrogen, and then it has the 2 branches. Each of those branches have an additional 3 hydrogens. Okay, so now what's left is we look over here and this doesn't look right. We know carbon wants to have 4 bonds and oxygen wants to have 2 bonds and 2 lone pairs. So we can finish our Lewis structure building off our understanding of the bonding patterns. Now that we have the Lewis structure, we can create our skeletal line structure. So beginning with this aldehyde group here, this functional group, this corner, right, represents this carbon, and then here's our CH2, and then here's our carbon with the 2 branches. And we'll go ahead and put our lone pairs since the directions asked us to. All right, so we had our condensed formula, our Lewis structure, our skeletal line, and now we simply add up the atoms, and it would be C5H10O. as the chemical formula. One last bit of practice before you get started on your homework. Now we have the full Lewis structure. So this is very straightforward. Let's do the condensed structure first. We'll start with this carbon atom here. We see we have CH3. And then we come here, and this carbon is only bonded to one hydrogen. And we'll go ahead and show everybody the double bond. And now we've gotten to the next carbon. And now we have NH2. So this Lewis structure, right, nitrogen, 3 bonds, and 1 lone pair. If we wanted to convert this into the skeletal line structure, very straightforward. There we are. And then last but not least, the chemical formula or molecular formula would be C3H7 nitrogen. Alrighty, so I hope that you have found this review of structural formulas helpful. Please take some time now to work a few homework problems to reinforce your understanding.